In a previous session, we know about work done. Now, the concept of work done is if displacement is there and with the application of the applied force, then we say the body do some, or the external force which is applied on that body do some work. Now, if we apply same kind of force but the masses of the two bodies are different, like this is a body of mass capital M and this is the body of mass small m. Now if we apply it and the condition is m is greater than small m, there are many conditions, but we simplify this criteria about that particular case. Now if we apply same kind of force between the two bodies, now due to that application of the force, the heavier body or the body of mass m will displace this much amount of displacement, and the small body displaces this much amount of displacement. So you apply same force, same amount of force, but the condition of the two bodies are different in the sense they are in their masses. So there are different mass, but you apply same kind of force due to that same application force, but due to the different kind of inertia, a body, one of the body displaces more and one of the body displaces less. So from that concept, one of the body displaces greater, that means its work done is greater compared to the body having a displacement which is a small one. So due to the fact that the mass are different, with the application of the same amount of force, the body work done different amounts. So there is a capacity of doing work of every kind of body. So this capacity of doing work is called the energy of the body possess. So there are different kind of position that will a body retain. Due to that, or depending on that particular positions or inertia, there are different kind of energy. Energy is nothing but the work done, but the extra term which is added to the energy is capacity of doing work. That means the energy, unit of energy and work done would be same. The unit of energy is nothing but the unit of work done, which is unit of energy equal to unit of work done, which is joule. But in this case, the energy is nothing but the capacity of doing work. Now, due to the defined position of the body, that energy can be categorized. In case of classical mechanics, as per the classical mechanics is concerned, that energy can be considered as the two type. One is kinetic energy, another is called potential energy. That kinetic energy comes from the condition of inertia of motion, and the potential energy comes from the term which is called inertia of rest. So due to the inertia of rest, the energy possessed by a certain kind of body is called potential energy, and due to the inertia of motion, the energy possessed by a particular body is called its kinetic energy. Now potential energy can be subdivided into many parts. Now there are two important parts which is included in your syllabus is gravitational potential energy and elastic potential energy. So there are two parts. One, potential energy is subdivided into two parts. One is gravitational potential energy and one is called elastic potential energy. Now kinetic energy are of different kinds. One is called translational kinetic energy, another is called rotational kinetic energy, and it's called vibrational kinetic energy. But we actually conclude in the portion of classical mechanics, that's why we deal with only translational kinetic energy, which is simply called kinetic energy. And in case of potential energy, we only deal with the gravitational potential energy. We know something about elastic potential energy. What is elastic behavior of that body, that we have to first know. The elastic behavior or elasticity is nothing but the retain its original position. Due to the inertia, everybody retains its original position, but if you apply a certain kind of force on that body, then body will regain its original position or tends to regain its original position. So by that property, by virtue of which the body wants to remain its original state and it can apply the amount of force on that body to regain its original position is called the elastic property or elasticity of the body. So due to that elasticity of that body, the energy possessed is called elastic potential energy. And what is gravitational potential energy? The body is situated in any position of that earth surface or in a gravitational pull. So due to that gravitational pull of attraction, the energy possessed by that body is called gravitational potential energy. So gravitational potential energy is nothing but the energy possessed by a body due to its position, shape and size. Now kinetic energy, as the body is moving, so there is a velocity. So due to that velocity, the energy required for that particular case of velocity requirement, so that's why the kinetic energy is nothing but the energy possessed by a moving body due to its movement. So there are two kinds of energy division. One is kinetic and one is potential energy. Kinetic energy is for the energy requirement for its movement, and potential energy is the energy requirement for its shape, size and position. Now we have to calculate the amount of potential energy, which is nothing but gravitational potential energy. So gravitational potential energy is depend on the reference frame. What is reference frame? Reference frame is somehow it is called you observe on a particular thing on a base of a something. That base in which you can observe with respect to that base is called its reference frame. So with respect to reference frame, we have to calculate the gravitational potential energy. That reference frame we deal with is the surface of the earth. So this is the surface of the earth, and the body is situated at the height of h from that surface of the earth. Now the body's mass is m. Those are the requirement. So the body having mass m at a height h from the surface of the earth. Now in this every cases, the acceleration due to gravity is acting downward. So if the body displaces from that position to that position, or for retaining that particular position, we have required the energy, and that energy is called the gravitational potential energy at that particular point. So gravitational potential energy is nothing but the work done on that particular body. So work done is nothing but force times displacement. Now force is nothing but that weight of that particular body. So force is m into g, and the height, that is the displacement in which the body retain at that particular position. So height is h. So the expression of gravitational potential energy is nothing but u, and that u is called the gravitational potential energy, which is force times the height. Force is nothing but the weight of the body, which is m into g, and the height is nothing but h. So the expression of gravitational potential energy is mgh. Now the expression of kinetic energy. Let the body in its initial position having the position A and the mass is m. In that particular position, we applied a particular kind of force which is F. Now the initial position, the body is at rest. Now the body is moving with the application of that particular kind of force and attain a particular velocity v at that displacement of s. Now the acceleration produced due to the force applied is A. So acceleration produced in the body due to the application of that force is A, and the body's mass is m, and it displaces the distances by a particular time interval, and the initial movement of that body is at 0. So that u is equal to 0. That means initial velocity is 0. So initially is at rest. Now due to the application of force, the body is moving. So due to that movement, there is a kind of energy, and that energy is termed as kinetic energy. Now we have required the force times the displacement. Now from the concept of Newton, F equal to ma, because m is the mass of the body and a is the acceleration. So there is a force which is m into s. So you have to calculate the kinetic energy, which is Ke, is nothing but F into S. So ma into S, but that S is unknown to us because the body is moving. So we have to calculate with respect to that final velocity attained by the body. Now by the equation v square equal to u square plus 2s. Why it is plus 2s? Because the body is accelerated. So v square is nothing but v square u square is 0 plus 2s. So s equal to v square by 2a. Now substituting this term in s, we get m into a into v square by 2a. So a cancel out, that would give half mv square. So this is the expression of kinetic energy possessed by the body. So kinetic energy is nothing but half times the mass times the square of the velocity. Thank you.